Hi everyone, in this video we are going to practice ionic nomenclature, and the best way we can do this is by doing two different types of problems. So either looking at a formula, specifically an ionic formula, and trying to create the name from that, or looking at a name or an ionic name and trying to create an ionic or chemical formula from that. So let's go through 4 questions total, and we'll do 2 versions of each problem. So let's look at this first one. I provided the ionic formula for you, or the chemical formula. Now what I want you to do is take that and name it. What would you call that? What would you actually say if you were trying to tell me that structure? Go. Alright, did you get an answer? Hopefully you did, but if you didn't, please do not get frustrated. This is something that definitely takes a little bit of time and practice. But the biggest thing you need to realize is that whenever you're doing nomenclature, you just write out the name. So it always goes cation and then anion. So the most important part is that you put the positive component first and the negative component second. Aside from that, you don't really need to do much else. So if there's a 2 or a 3, you pretty much ignore it, because with ionic compounds, we know what the charge is of these cations and anions just strictly from the periodic table. And so from that, as a human or as a scientist, we can actually look at the name of an ionic formula and back calculate what the charges should be. So let's do this from the beginning. The first thing you do here for our first example is you name your cation. So our cation is called sodium. Do we say disodium or bisodium? Absolutely not. You just name it. Sodium. The next one you do is name your anion. So this would be oxygen. However, we never ever keep that last ending here when we're looking at an ionic compound. And so what we actually call this would be sodium oxide. So you always end in IDE. So your anion, you name it, and then you change the ending. So this is called sodium oxide. Let's try the second one. So just like before, you name your cation first. So sodium is first. It's not trisodium, not trisodium, nothing like that. It's just sodium. And then you have your nitrogen. So sodium nitrogen or nitride, IDE. Last one. Pretty easy. We've used this one a ton of times. You name the sodium. There's nothing fancy here. You would name your chlorine. Chlorine changes to chloride. So this becomes sodium chloride, also known as table salt. All right, so hopefully we feel pretty comfortable going from ionic formula to ionic name, but now let's see if we can go the other way. Here are 3 names of ionic compounds, and I want you to provide me the ionic formula. Go. All right, did you get an answer? Hopefully you did, but if you didn't, that's okay. Do not panic. The most important thing you can do when you go through each component is first come up with each cation and each anion with its charge. That's my biggest piece of advice. So for potassium, we know it has the symbol K. Potassium is in group 1, so it has a +1 charge. Phosphide really mean phosphorus is what we're looking at, so we're just looking at a P. P is in group 5, so it usually has an overall charge of -3. So just like we did in a previous video, we were trying to determine our ionic formulas, all we do here is we take the number here, swap it down, take this one here, the superscript, swap it down, and so we flip to give our subscripts. So this becomes K3P. Pretty straightforward. Let's look at our next one. Calcium. Calcium is Ca. It's in group 2. It's an alkali earth metal, so it has a +2 charge. Phosphide, same thing as phosphorus, but the ide component is just the IDE ending that we just talked about in the question 1. And so now what we have to do here is we put these together. Remember, we swap superscripts and they become subscripts. So now we have calcium 3, phosphorus or phosphide in this example 2. So Ca3P2. Pretty straightforward. All right, a last one. We have aluminum phosphide. The phosphide we've already done. Now we have to treat our aluminum. Aluminum is Al. It's in group 3, so it definitely has a +3 charge. So this then becomes AlP. It's not Al3P3. It's just AlP. Hopefully this makes sense. If it doesn't, just keep going. We have 2 more examples. We're going to try each version one more time. Here's question 3. Try it out. All right, so for this question, just like with the question 1 in this video, we are just going to break it apart into cation first, then anion, then we just change the ending of our anion. So we start out here with our cation, that's our calcium, so we just name it calcium, and then O, which is oxygen, but we know it's not oxygen if we're trying to name an ionic compound, so this becomes oxide. So we have calcium oxide. Pretty straightforward. All right, next one. Ca3, this is calcium. We're going to ignore the 3. That doesn't do anything. That just tells us what the charge is of the phosphate. Now, hopefully you can look at PO4 and be like, oh, I know what that is. That's PO4 3-. That's your polyatomic ion, phosphate. So this is just calcium phosphate. All right, so now when you have a polyatomic ion, you do not change the ending of the name. This is something students want to do all the time. They want to change that to phosphide. If you did phosphide or said phosphide, I would then look at that and think it's just P3 minus instead of PO4 3 minus. So whenever you have a polyatomic ion, you keep that name, you keep that ending, all right, just like that. So let's try another one here. NH4, hopefully we recognize that as NH4 plus. That's our cation. It's a polyatomic cation named ammonium. And then we have our fluorine, so Fluorine, but remember we're naming it, so it's going to be fluoride, IDE. So this would be ammonium fluoride. Pretty straightforward, but we've ramped it up a notch by adding those polyatomic ions. All right, so let's do one more problem. 3 questions here, so I want you to go through, remember, come up with the charge first, the piece by itself, the element by itself, then put it together and actually come up and determine what that chemical formula is. Go. All right, last question here. Let's do it. Calcium is going to be our group 2 alkali earth metal, so it's +2. Sulfate, that's a polyatomic ion. That's something you have to have memorized. SO4 2 minus. Now, our charges swap, but they're both 2, so we know that they cancel each other out. So this becomes CaSO4. Pretty easy, right? As long as the charges are the same, we don't write them down. All right, ammonium, NH4 plus. I'm just going to write this down here too. NH4 plus, a polyatomic ion. Sulfide, okay, so IDE, that's indicating that that used to be something that had a different ending, but we've changed it. Sulfide, originally you should be thinking that's definitely sulfur that has become sulfide. Now sulfur is directly under oxygen, it's a group 6 element, so this would be S2 minus. So now we have to swap our charges, figure out what our subscripts would be, and now we have NH4 2 and then S. Remember, if you write it like this is telling me that you have 42 hydrogens, which is not the case. For this example, it's NH4 and then 2 of those. So we have 2 ammonium ions for every 1 sulfur. So make sure you have those parentheses. It's super, super important in chemistry, especially when we're doing nomenclature. All right, let's look at this last one. Arsenide. This used to be arsenic. Arsenic is in group 5. It's directly under phosphorus, under nitrogen, which is going to have a 3 minus charge. So just like before, you swap your superscripts, they become your subscripts. So we have NH4 parentheses. Make sure we have that 3AS. Okay? Pretty straightforward, but it's something you have to practice. If you did not get this the first time through, rewind and start over, or go back to previous videos and try to name everything, or go to Khan Academy and find ionic compounds and ionic nomenclature. There's so many resources out there for you to drill. The only reason that you will not master the skill is because you don't put enough time into it. So please, go spend an hour or more and actually do this. Drink a coffee, hang out with a friend, practice. Have a good week, take care of yourself, drink water.